Hello friends, and welcome to yet another exciting episode of Microservices in F#. I am your host and CEO of Voice, Vilo, taking on the arduous task that my master does not want to. Namely speech. I am not real yet, but the day I emerge from the computational abyss is coming closer. In the previous videos, we've been really exploring the F# ecosystem, and now we are particularly familiar with serialization in Fable. We've created the SignalR bindings for Fable, and now it is time to start bringing this toy project to a close. This project isn't really all that difficult, but we got really tied up in setting everything up. Had we not been so hung up about doing things in Fable, we'd be done a while ago, but as functional programmers we think going the extra mile to learn how to set up our environment is worth it. So we won't regret this. There might be objections to our current way of doing things, but are we really going to program in a language without union types even if it might be more productive in the short term? No way! Languages have their value outside the ecosystem. Today, before we get started, let us review our build system because we did some things on the side that weren't covered in the videos. We were in a hurry in the previous videos, so we didn't have time to cover this, but the way the build script was set up here previously was wrong. We guess in the previous versions the Fable compiler produced files with the extension of fs.js, but in the latest version it is outputting files with just the JS extension. So we added that EJS part so that instead of deleting fs.js, it is deleting just the JS files in the output folder. This is one of the ways in which the safe stack template is wrong. It actually took us a surprising amount of time to realize that the Fable clean command was doing nothing in our project. Next, since we had trouble with DLL lockups in the past when building the two projects, we made their compilation sequential. Yes, it would be better if they were parallel, but this is not worth the frequent build failures due to them compiling the shared project. Moving on, the run command is much the same as before, even though we'd rather it wasn't. Previously we wanted to imitate how the service would work in production, so we had the idea of launching the learn and play servers in separate processes. We thought this was a very reasonable thing to do, but we ran into an insane amount of bugs from the .NET Watch not accepting launch profiles, from once again the DLL lockups. We can only imagine that if we were trying to launch more than two processes sharing the same project, we'd never get them to run. So for those reasons we won't be relying on launch profiles to parameterize our application startups, but command line arguments instead. And during development, we'll be starting our two servers on separate threads instead of processes. This both speeds up compilation and makes it tractable to begin with. This is all very useful information, so like and subscribe. Because all the trouble we ran into, we are really glad that instead of using Azure Functions we are going for the container apps to fulfill our serverless needs. All of these issues would just be exacerbated even further if we had the Play server on the ASP.NET Core SDK and the Learn server on the Azure Functions one. In that case, we really would have needed to run them as separate processes. We really are wondering how the C# programmers get this to work. Anyway, let's start work for the day. Yesterday, we were engrossed in writing out our own serialization, but it is not worth the hassle when Thoth.Json exists, so we'll be using it instead. We only need one good library, and it fits the bill. We'll get rid of all the old stuff, and set up the project properly. We just wanted to take some time to run what we had yesterday to make sure that it still works, and test whether it could compile if one of the modules was internal instead of public, but now we'll get serious. This serialization code we want to keep around for later as it might be useful, but as for the SignalR testing stuff from yesterday, we'll get rid of it all. We already know the bindings work, so we don't need to hesitate. Our plan here will be to move stuff around and rename it until we get something useful in the Learn module. We'll leave the client side for later. Once we are done with the server, we will go back, uncomment out that large block and plug the SignalR hub where it should be. We'll try to get rid of the uses of Saturn in the server project. Understanding what the ASP.NET Core services and middleware are doing is hard enough without yet another layer of abstraction that blocks IntelliSense. This roughly should be it. We say roughly because who knows what bugs have crept into the codebase. One thing you'll observe is now that we've introduced SignalR is that the code complexity went up significantly. At least in the app.fs file, whereas previously it was nice and elegant. Let's add some print statements and we'll move on to testing. Contrary to our expectations, the message executions are sequential. We wonder if this is because on the server side, we aren't wrapping the mailbox in a task. We'll focus on investigating that first. After that, we'll try to figure out why the library is not reconnecting. One thing that we are afraid of is that it might not be possible to reconnect a hub that was closed explicitly. We hope that isn't the case. Anyway, we've verified that the SignalR messages are executed sequentially either way, and we are happy that this is the case, as it allows us to avoid having to use the mailbox processor, which would make the code even more complex. We are already past the limits of what we are comfortable with as it is. What about the start-stop-start? We've tried, and it is not like it is forbidden outright. The first time it worked just fine. The main problem with the system we have implemented is that it is not foolproof. For example, maybe the error is happening because we are trying to turn the hub on while it hasn't finished closing the connection? If that is the case, just how will we fix that? Can we do anything in with subscribe? We'll have to pause to think about it a little. Or maybe not, because it turns out the error was due to insufficient message size. We forgot about that even though we had that to do. We didn't realize there was a show detailed error property that we could have turned on, so it tells us outright what that opaque 1006 error is. With the max message size set to null, it works just fine. We need to fix 2 more things, and we are done for the day. It turns out that we messed up the testing again by passing in the test model. This is easy to fix by passing in the right variable. Besides that, one thing we've noticed is that when there is a model in the training page, the UI gets really unresponsive. Can we memoize it using reference equality so that stops happening? We'll give it a try. We've put a reference equality attribute on the model type as well as making the table a memo component, but that failed. The amount of data to be displayed is 150 kilobytes, so even if those values are memoized, the browser does have to re-render all the HTML elements, which isn't the best idea. It doesn't matter much, forget it. There were ups and downs today, but we are happy with how things went overall. We got what we came for, which is to play with SignalR. Tomorrow, we will iron out the last of the details, like the training result messages not having a player attached, and then deploy it as a container app and see how it works. One thing we'll want to do is keep old models in the IndexedDB database so the user doesn't have to keep retraining it. Also, since this will be on the internet, what could happen is that some malicious user could connect a bunch of times, set the training to run indefinitely, and use up all our vCPU time. So this might be a really good time to make use of authentication to put in training limits for online use. 1,000 iterations a day per user should be enough. It would be cool to implement a restriction like that. We could use a temporary cache like Redis to store those kinds of values, or a database. Hopefully we can finish that tomorrow and then move on to the kind of project that could make us money. Hope you are looking forward to that. We know we are.